Alright, so let's look at this problem. It's similar to the ones we've done previously, except I'm going to kind of augment the method of joints a little bit and give you some advantages. So what I'm going to do first is I'm going to look at the entire structure as an object, a body, a rigid body. And I'm going to say, okay, what's happening here at C is I have a reaction, Cy, at the roller. I'm going to come over here at the pin. I'm going to say I have a reaction, Ay, and I have a reaction, Ax. So how many total unknowns in terms of reactions on this free body? 3. And we know for a two-dimensional coplanar system like this, how many equations of equilibrium can I write? 3. So I'm going to find my reactions to start. Like many problems we've done before, when you have a pin's a good place to sum a moment because two of your reactions, Ax and Ay, pass through that point, create no moment. So I'm going to sum, right-hand rule is my sign convention, I'm going to sum moments about A and make sure the whole structure is in equilibrium. And when I do that, I've got to worry about the moment P1 and P2 and then my reaction. I'll start with P1. It's going to create negative moment. It has a magnitude of 9 kilonewtons and it has a moment arm of 4 meters. P2 also creates negative moment. It has a magnitude of 15 kilonewtons and a moment arm of 3 meters. Then I have Cy, which I assume is acting up. That's going to create positive moment. And it has a moment arm of 6 meters. So I should be able to solve for Cy. So what is that? I don't know what that is. Somebody help me with that. This is 36 and this is 45. Add those together, you get some odd number divided by 6. Mr. Coleman, what'd you get?
13.5.
Anybody else get 13.5?
Negative 13.5.
No? It's not that hard, guys. Help me out. Did you get that, Mr. Ellis?
10.5.
10.5?
13.5.
Oh, 13.5? All right. Now I'll come in and I'll sum forces in the y direction. Make sure I'm in equilibrium. So I have Ay acting up, Cy acting up, and P2 is acting down, which is minus 15. So from that I can find that Ay should be, what is that, 1.5. And then I can sum forces in the X direction. I have Ax positive, and P1 is also positive. So it looks like Ax would be negative 9. So what does that? How does that help me? Well, it allows me now, if I look at joint C or joint A sometime in my sequence, I don't have unknowns anymore for the reactions. I have values. So that could help you out. Kind of just to get the problem started, we can see by zero force members that these two are out. So I could say by inspection that I have zero force members, and therefore the force in CD is equal to the force in DE, which is equal to 0. And what this changes for us a little bit is the next move in our solution. You have a chance. You have something to think about. You can go to joint F, 1, 2 unknowns. You can now go to joint C. With this being 0, I have 1, 2 unknowns also. So you could either do joint F or C as a starting place and get 2 equations and 2 unknowns. So at this point, you could go either to joint F and or to joint C. So I'm kind of doing them in parallel because they're not connected. You can do these independent of each other. So if I were going to joint F, I would assume I have a force in tension of AF and a force in tension here of EF, and then let's not forget our P1 force, which is equal to 9 kilonewtons. I can solve that system. I can also come over here to C and I can assume a force in BC and a force in CE. But now I know CY. So CY is going to act just like a reaction or an external force. So I'll just draw it on there as a 13.5 kilonewton force acting up. And conveniently for us, we know that is a 3-4. So unlike our previous problems where we start with one joint and we work our way through, so for example an early error would propagate all the way through, now I have 2 kind of independent places to start. So I'll do F real quick to start. So if I sum forces in the x direction, make sure equal to 0, I have the force EF to the right and then my 9 kilonewton force. So it looks like the force in EF is minus 9 kilonewtons. Now this one might be a little uncomfortable for you to think about, but if I sum forces in the y direction now, what do I get? I just get minus AF acting down. So what does AF have to be equal to? 0. Kind of odd. But if you think about it, here at F, with only a horizontal force, there's nothing required vertically to maintain equilibrium at F. Then I'll put a little divider here, and then we'll look at C. Now looking at joint C, should I sum forces in the X first or sum forces in the Y first?
Y.
Yeah. Only CE has a Y component, so let's do that. So assuming up is positive, I'll sum forces in the Y direction. So this will be 4/5 of the unknown in CE acting up plus my reaction force of 13 kilonewtons. So I should be able to solve for the force in CE. It looks like it's going to be negative, and somebody will have to multiply this. So it should be 13.5 times 5 divided by 4. What's that equal to?
$16.875.
Somebody else get that? Cool. And then we'll finish it off by summing forces in the x direction. In this case, we have force BC acting to the left, negative, and then 3/5 of the value we just found, also acting to the left. So if we plug that value into there, we should be able to find the force in BC. It looks like it's going to be positive. I think. Yeah. The negatives cancel. So what is that? What's 3/5 of that? 3/5 of 16.875. Anybody get that?
10.125.
Anybody else get that?
Mm-hmm.
That seems reasonable. And I don't have all the forces. Let's see what I've got. So I found this one, this one, this one, this one, right? And those two are zero force members. So I'm just down to 1, 2, 3. So I'm going to go ahead and stop this problem. But if you wanted to finish it, you would just go here to B, do a section at B. You should be able to find this one and this one, and then we would just be left with the diagonal member. And at that point, I think you would probably want to go to A. But I might let you finish that one for homework. Okay? So any questions about how we've gone this far, this part of it? All right.